Okay, so simplest radical form here. We're still simplifying radicals. This time we just added the variables in. So looking at the second example, this one's a little intense because there's a lot going on. There's not just one variable, there are multiple variables, and I also have a number in there as well. So added a lot to kind of your plate there. So the first thing you're going to start off with is, and I'm just going to make a little note of this. Let's use I don't know. Let's just use black. So let's start here. Start by splitting up the radicals. So looking at this example 2, I want to split that up. I'm going to split that up into actually 3 different pieces because that's what I have to start off with. I'm going to look at the square root of the number 90 separately from looking at my square root of x to the 5th. And I'm also going to look at that separately from my square root of y to the 2nd. So starting off with 90, that's numbers, that's a review from yesterday, or last lesson, where you want to get the factors of 90. I know right off the bat that 9 times 10 is going to get me 90, and 9 is a perfect square, so I'm pretty pleased with that one. So I know also that I could do 3 and 30, but neither 3 and 30 are perfect squares. We can do 2 and 45, but again, not perfect squares. That's why I'm going with the 9 and the 10. So I can break the square root of 90 up into the square root of 9 times the square root of 10, because 9 times 10 gets me back to that original 90 that I had. We're just factoring things, really. And then this square root of x to the 5th, just like we did above with x to the 7th, how many x squareds can I break that x to the 5th up into? Square root of x squared times the square root of x squared, that gives me 4. I need 1 more to get to that 5. And so then the square root of y squared, I don't really need to break that up into anything because it is the square root of y squared already. It's already broken up into squareds. All right, so now we just kind of put it all back together here. The square root of 9 comes out as a nice normal 3, but the square root of 10 is not a perfect square, so that stays in the radical. The square root of x squared is x, times the square root of x squared is x, but again, that plain old square root of x stays in the radical because it's not a perfect square. It doesn't have that even exponent. And then the last piece, that square root of y squared, just like the square root of x squared is x, the square root of y squared is y. And now we just put all these things back together using only one radical. Let's make a note of that. When we're doing this, your final answer should only have one root or radical. There shouldn't be multiple ones like I have right now, so I'm going to have to combine those. All right, so let's get a final answer here in red. My 3 is on the outside of the root. X times x can change to x squared. Y is also on the outside of that radical. And then under my radical, I have 10 and an x. So there is my simplified answer in simplest radical form. 3x squared y square roots of 10x. Boom. I want to circle that somehow, but maybe I'll just highlight it.